Hey, this is Sleeper, and we are finishing up this module of Introduction to Web Applications, starting with the development frameworks and APIs. In addition to web servers that can host web applications in various languages, there are many common web development frameworks that help in developing core web application files and functionality. With the increased complexity of web applications, it may be challenging to create a modern and sophisticated web application from scratch. Hence, most of the popular web applications are developed using web frameworks. As most web applications share common functionality, such as user registration, web development frameworks make it easy to quickly implement this functionality and link them to the front-end components, making a fully functional web application. Some of the most common web development frameworks include Laravel, PHP, usually used by startups and smaller companies as it is powerful yet easy to develop for. Express Node.js, used by PayPal, Yahoo, Uber, IBM, and MySpace. Django, Python, used by Google, YouTube, Instagram, Mozilla, and Pinterest. Rails, Ruby, used by GitHub, Hulu, Twitch, Airbnb, and even Twitter in the past. It must be noted that popular websites usually utilize a variety of frameworks and web servers, rather than just one. APIs. An important aspect of back-end web application development is the use of web APIs and HTTP request parameters to connect the front end and the back end to be able to send data back and forth between front end and back end components and carry out various functions within the web application. For the front end component to interact with the back end and ask for certain tasks to be carried out, they utilize APIs to ask the back-end component for a specific task with specific input. The back-end components process these requests, perform the necessary functions, and return a certain response to the front-end components, which finally renders the end user's output on the client side. Query parameters. The default method of sending specific arguments to a web page is through GET and POST request parameters. This allows the front-end components to specify values for certain parameters used within the page for the back-end components to process them and respond accordingly. For example, a \search.php page would take an item parameter which may be used to specify the search item. Passing a parameter through a GET request is done through the URL \search.php $item equals apples, while POST parameters are passed through this POST data at the bottom of the POST HTTP request. Query parameters allow a single page to receive various types of input, each of which can be processed differently. For certain other scenarios, web APIs may be much quicker and more efficient to use. The web request module takes a deeper dive into HTTP requests. Web APIs. An API, an application programming interface, is an interface within an application that specifies how the application can interact with other applications. For web applications, it is what allows remote access to functionality on back-end components. APIs are not exclusive to web applications and are used for software applications in general. Web APIs are usually accessed over HTTP protocol and are usually handled and translated through web servers. A weather web application, for example, may have a certain API to retrieve the current weather for a certain city. We can request the API URL and pass the city name or city ID, and it would return the current weather in a JSON object. Another example is Twitter's API, which allows us to retrieve the latest tweets from a certain account in XML or JSON formats, and even allows us to send a tweet if authenticated, and so on. To enable the use of APIs within a web application, the developers have to develop this functionality on the back end of a web application by using the API standards like SOAP or REST. SOAP. The SOAP, Simple Objects Access, standards share data through XML, where the request is made in XML through an HTTP request, and the request is also returned in XML. Front-end components are designed to parse this XML output properly. The following is an example SOAP message. SOAP is very useful for transferring structured data, for example, an entire class object, or even binary data, and is often used with serialized objects, all of which enables sharing complex data between front-end and back-end components and parsing it properly. It is also very useful for sharing stateful objects, for example, sharing or changing the current state of a web page, which is becoming more common with modern web applications and mobile applications. However, SOAP may be difficult to use for beginners or require long and complicated requests even for smaller queries like basic search or filter queries. This is where the REST API standard is more useful. REST. The REST representational state transfer standard shares data through the URL path. For example, search /users/1, and usually returns the output in JSON format. For example, user ID 1. Unlike query parameters, REST APIs usually focus on pages that expect one type of input passed directly through the URL path, without specifying its name or type. This is usually useful for queries like search, sort, or filter. This is why REST APIs usually break web application functionality into smaller APIs and utilize these smaller API requests to allow the web application to perform more advanced actions, making the web application more modular and scalable. Responses to REST API requests are usually made in JSON format, and the front-end components are then developed to handle this response and render it properly. Other output formats for REST include XML, XWWW form URL encoded, or even raw data. As seen previously in the database section, the following is an example of a JSON response to the GET category posts API request. REST uses various HTTP methods to perform different actions on the web application. GET request to retrieve data, POST request to create data, PUT request to change existing data, and delete request to remove data. So we'll start our instance and our target. And our question here, use get request \index.php ID equals 0 to search for the name of the user with ID number 1. So we'll wait for this to load here. Should be pretty quick. If not, we can just load it in our Edge. Okay, that loaded. Let's see if this will load. Oh, we need the request. And ID equals 1. Maybe we'll have to curl or something. Let's see. Okay. We will, oh, there it is. So it loaded. Oh, It was hidden. Okay, so it's super admin. If we're 0, what does that say? User does not exist. Okay, so we found our answer. It was just hidden. Carrying on. Common web vulnerabilities. If we were performing a penetration test on an internally developed web application or did not find any public exploits for a public web application, we may manually identify several vulnerabilities. We may also uncover vulnerabilities caused by misconfigurations, even in publicly available web applications, since these types of vulnerabilities are not caused by the public version of the web application, but by a misconfiguration made by the developers. The below examples are some of the most common vulnerability types for web applications, part of OWASP Top 10 Vulnerabilities for Web Applications. Broken authentication or access control. Broken authentication and broken access control are among the most common and most dangerous vulnerabilities for web applications. Broken authentication refers to vulnerabilities that allow attackers to bypass authentication functions. For example, this may allow an attacker to log in without having a valid set of credentials, or allow a normal user to become an administrator without having the privileges to do so. Broken access control refers to vulnerabilities that allow attackers to access pages and features they should not have access to. For example, a normal user gaining access to the admin panel. Another example, College Management System 1.2 has a simple auth bypass vulnerability that allows us to log in without having an account by inputting the following for the email field: SQL injection, and using any password with it. Malicious file upload. Another common way to gain control over web applications is through uploading malicious scripts. If the web application has a file upload feature and does not properly validate the uploaded files, we may upload a malicious script, for example a PHP script, which will allow us to execute commands on the remote server. Even though this is a basic vulnerability, many developers are not aware of these threats, so they do not properly check and validate these uploaded files. Furthermore, some developers do perform checks and attempt to validate uploaded files, but these checks can often be bypassed, which would still allow us to upload malicious scripts. For example, the WordPress plugin Responsive Thumbnail Slider 1.0 can be exploited to upload any arbitrary file, including malicious scripts, by uploading a file with a double extension. For example, shell.php.jpg. There's even a Metasploit module that allows us to exploit this vulnerability easily. We have command injection. Many web applications execute local operating system commands to perform certain processes. For example, a web application may install a plugin of our choosing by executing an operating system command that downloads that plugin using the plugin name provided. If not properly filtered and sanitized, attackers may be able to inject another command to be executed, alongside the originally intended command, for example as the plugin name, which allows them to directly execute commands on the backend server and gain control over it. This type of vulnerability is called command injection. This vulnerability is widespread, as developers may not properly sanitize user input or use weak tests to do so, allowing attackers to bypass any checks or filtering put in place and execute their commands. For example, the WordPress plugin Plainview Activity Monitor 2016-12-28 has a vulnerability that allows attackers to inject their command in the IP value by simply adding pipe command after the IP value. And SQL injection, SQLi. Another very common vulnerability in web applications is a SQL injection vulnerability. Similarly to a command injection vulnerability, this vulnerability may occur when the web application executes a SQL query, including a value taken from user-supplied input. For example, in the database section, we saw an example of how a web application would use user input to search within a certain table, with the following line of code. If the user input is not properly filtered and validated, as is the case with command injections, we may execute another SQL query alongside this query, which may eventually allow us to take control over the database and its hosting server. For example, the same previous College Management System 1.2 suffers from a SQL injection vulnerability, in which we can execute another SQL query that always returns true, meaning we successfully authenticated, which allows us to log into the application. We can use the same vulnerability to retrieve data from the database or even gain control over the hosting server. We will see the vulnerabilities again and again. We will see these vulnerabilities again and again in our learning journey and real-world assessments. It is important to become familiar with each of these, as even a basic understanding of each will give us a leg up in any information security realm. Later modules will cover each of these vulnerabilities in depth. So, to which of the above categories does the public vulnerability CVE 2014 6271 belong to? So if we just copy this, that's the only instance of that on this page. Let's Google it. We'll check the first option here. Processes trailing strings after function definitions and the values of environmental variables. It sounds like command injection. So we'll try command injection. There we go. And last but not least, public vulnerabilities. The most critical backend component vulnerabilities are those that can be attacked externally and can be leveraged to take control over the backend server without needing local access to that server. For example, external penetration test. These vulnerabilities are usually caused by coding mistakes made during the development of a web application's backend components. So there's a wide variety of vulnerability types in this area, ranging from basic vulnerabilities that can be exploited with relative ease to sophisticated vulnerabilities requiring deep knowledge of the entire web application. Public CVE. As many organizations deploy web applications that are publicly used, like open source and proprietary web applications, these web applications tend to be tested by many organizations and experts around the world. This leads to frequently uncovering a large number of vulnerabilities, most of which get patched and then shared publicly and assigned a CVE, a common vulnerabilities and exposures record and score. Many penetration testers also make proof of concept exploits to test whether a certain public vulnerability can be exploited, and usually make these exploits available for public use for testing and educational purposes. This makes searching for public exploits the very first step we must go through for web applications. Tip: the first step is to identify the version of a web application. This can be found in many locations like the source code of a web application. For open source web applications, we can check the repository of the web application and identify where the version number is shown, for example in version.php page, and then check the same page on our target web application to confirm. Once we identify the web application version, we can search Google for public exploits for this version of the web application. We can also utilize online exploit databases like ExploitDB, Rapid7DB, or Vulnerability Lab. The following example shows a search for WordPress public exploits in Rapid7 database. We would usually be interested in exploits with a CVE score of 8 to 10 or exploits that lead to remote code execution. Other types of public exploits should also be considered if none of the above is available. Furthermore, these vulnerabilities are not exclusive to web applications and apply to components utilized by the web application. If a web application uses external components, for example a plugin, we should also search for vulnerabilities for these external components. Common Vulnerability Scoring System, CVSS. The Common Vulnerability Scoring System, the CVSS, is an open source industry standard for assessing the severity of security vulnerabilities. This scoring system is often used as a standard measurement for organizations and governments that need to produce accurate and consistent severity scores for their systems' vulnerabilities. This helps with the prioritization of resources and the response to a given threat. CVSS scores are based on a formula that uses several metrics: base, temporal, and environmental. When calculating the severity of a vulnerability using CVSS, the base metrics produce a score ranging from 0 to 10, modified by applying temporal and environmental metrics. The National Vulnerability Database, NVD, provides CVSS scores for almost all known publicly disclosed vulnerabilities. At this time, the NVD only provides base scores based upon a given vulnerability's inherent characteristics. The current scoring systems in place are CVSS version 2 and version 3. There are several differences between the two versions to the version 2 and version 3 systems, namely changes to the base and environmental groups to account for additional metrics. More information about the differences between the two scoring systems can be found here. So the CVSS scoring ratings differ slightly between V2 and version 3, as can be seen on the following tables. The NVD does not factor in temporal and environmental metrics because the former can change over time due to external events. The latter is a customized metric based on the potential impact of the vulnerability on a given organization. The NVD provides a CVSS version 2 calculator and a version 3 calculator that organizations can use to factor additional risk from temporal and environmental data unique to them. The calculators are very interactive and can be used to fine-tune the CVSS score to our environment. We can move over each metric to read more about it and determine exactly how it applies to our organization. Below is an example view of the CVSS version 3 calculator. You can play around with the CVSS calculator and see how the various metrics can be adjusted to arrive at a given score. Review some CVEs and attempt to arrive at the same CVSS score. How does the CVSS score change when you apply temporal and environmental metrics? This handy guide is extremely useful for understanding the version 2 and version 3 and how to use the calculators to arrive at a given score. Backend server vulnerabilities. Like public vulnerabilities for web applications, we should also consider looking at vulnerabilities for other backend components, like the backend server or the web server. The most critical vulnerabilities for backend components are found in web servers, as they are publicly accessible over the TCP protocol. An example of a well-known web server vulnerability is the shell shock, which affected Apache web servers released during and before 2014 and utilized HTTP requests to gain remote control over the backend server. As for vulnerabilities in the backend server or the database, they are usually utilized after gaining local access to the backend server or backend network, which may be gained through external vulnerabilities or during internal penetration testing. They are usually used to gain higher privileged access on the backend server or the backend network, or gain control over other servers within the same network. Although not directly exploitable externally, these vulnerabilities are still critical and need to be patched to protect the entire web application from being compromised. So it's asking, what is the CVSS score of the public vulnerability CV 2017-0144? So we'll Google it. And it's asking for the CVSS score. Usually these are done here. Base 8.1, according to the version 3. So we'll try that. 8.1. And we'll take a look. CVS 8.0, 8.1 high maybe? Okay. What version? Maybe the second version, 9.3. We'll try it 9.3 high. We'll just try 9.3. There we go. So it wanted the version 2 base score. And here we go. We have some next steps. So in this module we have learned some, but by no means all web application basics. We should now have a fundamental understanding of how a web application is built, how it works, and what dangers it can introduce into a corporate environment. It is important to take a hands-on approach to develop our understanding further and apply the topics taught in this module. We recommend reviewing the material in combination with developing a small web application. Some next steps that can be taken are: set up a VM with a web server, create an HTML page, design it with CSS, add some simple functions with JavaScript, program a simple web application, connect your web applications to the database, experiment with APIs, test your application for various vulnerabilities and security holes, and try to adjust your code and configurations to close the vulnerabilities. Developing a small web application will provide a much deeper understanding of the structure and functionality. Learning how to set up and manage such a web server, the database's role, and how the individual pieces of code are linked together is an invaluable experience. The Web Requests and JavaScript Deobfuscation Academy modules will help to build on the knowledge presented in this module. The module Hacking WordPress and other similar modules related to OWASP Top 10, such as SQL Injection Fundamentals, are great next steps into penetration testing web applications, and learn more about web application vulnerabilities and exploitation. Finally, to apply what we learned from these modules, we can jump into some easy boxes on Half the Box and finish. So that's been part 3, the last sections of the Introduction to Web Applications module. And starting next time, we will be going through the next open module that I have, Attacking Web Applications with FUF. So once again, my name is Sleeper, and that's a wrap. Until next time.